Hi, welcome to another mini lecture on precalculus. Today's topic is sketching the graph of y is equal to a times sine of x plus c, or y is equal to a times cosine of x plus c. So what you see here now is the beginning of double action. So far we have learned how a single action works on a graph. Now we are combining two of them at the same time. Let me just remind you. So let's just concentrate on sine. So we have left to right. So in any of these problems, you start with a basic graph like sine of x. Then we learn what? Then we learn if you double this, what happens? So 2 sine of x, we said this is a scaling vertically by a factor of 2. Scale vertically by factor of 2. What does that mean? Plain language, twice as tall. Then we learn what happens if you have sine of 2x. This is scaling horizontally by a factor of 1/2. So this is compressing. So let's make it clear. Compress horizontally by a factor of 2. In other words, we say scale by 1/2. Then we learned about y is equal to sine of x plus 2. So this would be shift left by 2. Then we learn about sine of x, and then later on plus 2. This was shift up by 2. So we had to recognize the difference between these type of transformations. So these two are scaling, that the graph stretches or shrinks, and these two are shifts. The graph goes up or down or left or right. Now we are going to take a look at the situation where we have two of these actions combined. So we have a factor in front and a factor being added inside two activities, either sine or cosine. Let's see how does this work. So here is example 1. 5/2 of sine of x minus pi third. So two activities. So one is that we are going to scale the picture vertically by 5/2. So we're going to give 5/2 times taller. Well, if it was a whole number, it would be easier to talk about it, like twice as tall or 3 times as tall. This is 2.5 times as tall. That's one action. So this is scale vertically by 5/2. The other action that we have is this subtraction minus x minus pi third. What does that mean? That's a shift to which direction? Was it left or right? We learned that when you subtract, we shift to right. So shift right. Now, one of the nice things that we get here is that if you have an activity in the x direction, another activity in the y direction, you can do either of them first and the other one next. It would not make a difference. So this is influencing the data in the y direction. It is vertical activity, And this one is a horizontal activity. So the two of them do not interfere with each other. You can do x first and then y next, or y first and then x next. We also learn how to do this thing specifically for sine or cosine, but if you learn the idea in terms of shifting or scaling, the idea applies to any function. It doesn't have to be any specific sine or cosine. It can be a quadratic, cubic, whatever it is. Exact same set of ideas apply there as well. So what do? We start with our basic graph. So a basic graph, as usual, we have uh, these 5 points to follow. Is that right? So we have a graph of sine. Step one, suppose I want to make it 2.5 times taller. So 1, 2.5 times taller, it brings it here. 0, whatever you multiply by, just zeros. These points are stuck. -1, you make it 2.5 times bigger, so you're down here, -2.5. And again, this is a 0, so it stays where it is. So by now we have done that one. We finished with multiplying by 2.5. Next, we are going to handle the issue of moving to the right by pi third. So pi third, again, the software is being very friendly. It has taken this picture from 0 to pi. You see that it has divided to 6. Let's count it, like 1, 2, 3, 4, 5, 6. So pi third translates to 2 blocks of this. This is pi, a third of it will be here. Is that right? So moving to the right by pi third means I came here, this one came here, this one came here, this one came here, and this one came here. Okay, so so when I multiplied by 5.5, I came to this tall red curve. Then I let the pi third take effect, and now I am ending up with this green curve here. Is that right? So this is y is equal to 5/2 of sine of x minus pi third. And this is y is equal to just 5/2 of sine of x. So these are the steps. Now, that's idea, as I mentioned. This is general, applicable to any function. Now we can go ahead and do so-called point tracking applicable to sines and cosines, and emphasize the coordinates of those 5 important points and get our answer done like that. So we are going to continue in that way. Okay, notice that we explain the solution by physical movement. Like we talked about scaling and making things taller by shifting, moving the picture pi third to the right. There's also an algebraic way of doing this, which is what we have been doing in most examples so far. We can do it that way as well. That means that you make a table. So how do we make a table? We say, okay, let's start with input of the function, which is x minus pi third. And then we are calculating sine of that quantity, x minus pi third. Okay, so we go through our favorite angles, that this quantity, if it is 0 or pi over 2 or pi or 3 pi over 2 or 2 pi, then this column will be simply 0, 1, 0, minus 1, 0. And next we come and say, well, neither the input nor the uh, output are these quantities. Rather, I want 5 half times this. So 5 halves times sine of x minus 5 third. So what does that mean? I have to multiply every quantity by 5 halves. So I just multiply 5 halves, 0, 5 minus 5 half, this is 0. Uh, just as importantly, the question is, well, what are the x's that I'm going to use? What should x be so that x minus pi third becomes 0? So all that you have to do is to set x minus 5 third equal to 0 and solve that. You get x equal to pi third. So it's going to be pi third. And then you repeat this process for each of these 5 points. So here's another example. Let's put it here. So if x minus 5 thirds, so I'm now going to look at this. When does that become equal to 5 halves? Well, take the 5 third to the other side, pi third to the other side, and add them. So I take a common denominator. This becomes 3 pi. This becomes 2 pi. That is 5 pi 6. So when x is 5 pi 6, then x minus pi third is 1. And I know that the sign of that, then x minus pi third is pi over half. Sine of it is 1. And the 5 half times sine of that is going to be 5 halves. So what point are we referring to? Let's label these things. So let's give them some names. So this is the point A. The point A would be here. This is point B. Uh, point B is right up here. This is point B. Notice that the height or the maximum occurs at 5 pi 6. So it's asking us to figure out where is the maxima. Let's count it. Each of these blocks we said is pi 6. And by the time I made it here is 5 pi 6. And my height is 5 halves. So you can either use the pen to mark it at that spot, or you can give the coordinates and locate those points in then you're all done. Same thing for points C and D and E. We have to calculate their location C, D, E, see where did they go. So for example, what would be the x coordinate? Well, that's going to happen when x minus pi third, when x minus pi third is equal to pi. So I take a pi third to the other side, so pi plus pi third. Take a common denominator, multiply this by 3, becomes 3 pi, plus another pi is 4 pi third. So this is 4 pi third. I realize I should have done all of these things in green because this is the final graph that we have. This is pi third. This is 5 pi 6. It's 4 pi third. Perhaps it would be easier if we think about this as 2 pi 6, 5 pi 6, 8 pi 6, and so on. So make all the denominators the same so the progression is easier to see. And then you go ahead and find D and E as well. And or maybe you want me to help you out with this one. So let's continue. So what is the x location at which x minus pi third? When is it that x minus pi third becomes 3 pi half? So we are catching the x that's responsible for that. So x is 3 pi half. And now I add pi third to it, take a common denominator which is 6, multiply the first one by 3, the second one by 2. When I add them, I get 11 pi 6. So when x is 11 pi 6, 11 pi 6 is right here. This is happening at 11 pi 6. So you have to count 11 blocks until you hit there. And finally, the last point, x minus pi third has to be equal to 2 pi. So x is going to be 2 pi plus pi third. And then I take a common denominator. This becomes 6 pi and another pi. That is 7 pi third, or 14 pi 6 if you want uh, all of them with the same denominator. That brings us to the final destination. So again, uh, two ways of understanding what's happening here. One is in a language of movements and transformations. So we make things taller, we make things shorter, we move things to the right or left. That's the more core value of this assignment. The other one is just practicing the sines and cosines. Happens to have these 5 important points, and then we are tracking the points. So two styles, point tracking, and the other one is by transformations. So let's practice. Here is 3 times sine of x plus 2 pi third. So what I want you to do to pause this thing, solve the problems both possible ways, compare your answers, make sure you got the same, and come back and double check your answer with what we have here. So uh, exact same as this, we start with the grandfather of all of these graphs, which is just sine of x. So by now we should be able to do that in our sleep. So this is maximum, this is the midline, this is the minimum, this is another midline, and this is one cycle of sine. So you make a nice wavy curve. So you have y is equal to sine of x. Now you choose which one of these two you want to do first. You said one x, one y activity. It's your choice what you do first. That's not going to be the luxury that we are going to have in more challenging problem where both movements are in the same direction. If both of them are in x, or both of them are in y direction, then it makes all the difference which one you do first, which one you do second. But when you have one in x, one in y, try it both ways, you notice that you will get the same answer. So here what we did is that we multiplied by 5 halves. Here what we do is that we multiply by 3. Later on we're going to call this thing amplitude. So this another name for this thing is amplitude. So when you are playing with the sound equipment and you say increase the amp and such, that is what is meant. So double and triple. 0, of course, when you multiply by anything, you still have 0. Multiplying by 3, well, this time we have multiplying by whole number, so it's easier to talk about this. We have a picture, so that means 3 times as tall. Sometimes students make a mistake with thinking that moving up by 3. That's not what we're doing. If we were moving 1 up by 3, we will be at 4, not at 3. We are multiplying by 3. We are making it 3 times as tall with respect to the midline, which is the x-axis now. So it was minus 1 becomes minus 3, 1 becomes 3, and so on. Stage 2, what does this do? Adding, so changing x to x plus 2 pi third, what kind of shift does that occur? First of all, it is horizontal activity. And here's the main question for you, left or right? If you remember, this is shift to left by by whatever that number is, 2 pi third. So once again, these blocks, each of these blocks, you see conveniently, each of them is pi 6. So 2 of them becomes pi third, and 4 of them becomes this. So another way of seeing this when we are playing with the picture, is 2 pi third is the same as 4 pi 6, and uh, the software is trying to help you to get all the points going. So not only we need this high point here, but also uh, we want to divide by 3. So each of these things becomes pi 6, and we are moving left by 4 pi 6, 4 blocks. So we come here. So our starting point is that location. This was 3 blocks to the right. When you go 4 to the left, you're going to be here. 6 block to the right, 4 to the left. This was 4 to the left here, and 4 to the left of this one. One thing you want to pay attention to is that uh, from one critical point to the next is the same distance, so you don't want to go wrong. Like this is 3 blocks, 3 blocks, again 3 blocks, and again 3 blocks. So that's, you can guide your hand to make sure you are not creating a crooked picture or something. So here is my so I forgot to put this point down here, and of course here. And uh, so you could of course move to the left, and then take this black picture, move to the left, and then make it 3 times as tall. You'll see that you get exactly the same thing. Now I encourage you to follow that table method that will give you the coordinates for all the points that you want, if that is necessary, but I think the language of movement is a lot faster, less error prone, and much more meaningful. Sorry. How about this one? So uh, 3 times as tall, so we are doing scale vertically by factor of 3, so triple the height, if you wish to call it like that. And then what does this do? This is gonna go, which direction is that now? Shift, what do you say, shift right by 2 pi third, and we learn our lesson that counting blocks 4 pi 6 is easier to follow. So the original picture is that of a cosine. Cosine, you remember, has these 5 important locations. So we make a wavy curve through these. Well, I didn't do a good job. Not at all. Let's see. This is supposed to be here. 3 times as tall. So 3 times as tall means we are here. Move to the right by 2 pi third is 4 pi 6. Move everybody to the right by 4 blocks. So this point is going to come, here's 4 blocks. Here's 4 blocks for this one. Here's 4 blocks for this one. And 1, 2, 3. You need good eyes. So there, I forgot this one. It's also 4 blocks. Okay, so that's our final answer. So again, you locate these 5 points with your pencil, and this is going to make the curve through them. If you have a hard time locating a point, you need extra help, then you can use this point plotter to give you the point based on the coordinates. For that, of course, you need to make your table, uh, get the x and y coordinate. Once you have the x and y coordinates, so here you give a x, y coordinates to this, which that one then utilizes the pen and puts a dot for you. But I trusted that you can do this thing by your hand. You've been playing video games since forever, so pointing to a specific location probably is going to be easier for you. But if you wish to play with both of them, might be fun just to do it that way. Do we have another example? Well, something similar to that. What's the difference? What's the difference between these two? Minus pi third, minus 2 pi third, we went to the right. What do we do here? So of course this one, this same thing, we are going to go move left. So let's be quick with this thing. So we have a picture that goes like this. So you so 3 times as tall. So these are the points. So you notice how quick this is compared to making tables. And so we want to qualitatively understand what is happening. Left by, we learned our lesson 4 pi 6, 4 blocks to the left, 4 blocks to the left. So 1, 2, 3, 4 blocks. And here 4 blocks, and here is that right? 4 blocks, and this is 4 blocks, and this is 4 blocks here. So if I'm not mistaken, to double check, we have to have a gap of 3 blocks between any two consecutive points. So here we go. This is so I suggest again you use your pen to pinpoint those points, and once you're done with that, you use this for drawing the curve. If you want to make your table and get your final x and y's, then you can enter the points by the point plotter and then be done. But that's going to take quite a bit longer. Okay, so what is it that we learned today? What we learned is combination movement. So y is equal to a sine of x plus c meant that this movement and that this transformation are being combined. So we have 4 types of transformations. All 4 of them could be combined, and to make it even more interesting, we could have some reflections as well. When you go to my website, you see a long list of like 24 different kind of movements you can investigate. But let's do them one at a time and enjoy while we are doing it. Okay, until next time, good luck and God bless.